The morning of July 14th, 1944, Sergeant Joseph Apple stood in a forest clearing near Cerisy-la-Forêt, France, staring at a problem that had killed more American soldiers in 6 weeks than the entire D-Day landing. In front of him sat a Sherman tank, its bow pointed toward a wall of earth and vegetation that rose 12 feet high, roots intertwined like iron cables, branches forming a canopy so dense that even noon sunlight couldn't penetrate. Behind him, stretching back toward the Normandy beaches, lay 40,000 American casualties, the bodies of men who'd discovered that liberating France meant fighting for every 100-yard square of farmland, one murderous hedgerow at a time. Apple was a welder, not a combat soldier. 28 years old, hands scarred from years of working steel, assigned to the 111th Ordnance Company. His job was to fix broken equipment, not solve tactical nightmares. But that morning, standing next to Lieutenant Arthur Brooks under camouflage netting so thick the Germans couldn't see what they were doing, Apple was holding a cutting torch and staring at a pile of twisted German steel that was about to change the war. The steel came from Hitler's Atlantic Wall, specifically from the Czech hedgehogs, those massive iron obstacles the Germans had welded together and planted by the thousands across every invasion beach from Calais to Cherbourg. 3 angled beams meeting at the center, each beam 6 feet long, designed to rip the bottom out of any landing craft that tried to reach the sand. On June 6th, the Allies had blown through them, over them, around them. Now those same obstacles, cut apart and dragged inland by army engineers, were piled in salvage yards across Normandy. Scrap metal, useless. Except Apple was about to turn them into teeth. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching. From today, the hedgerows of Normandy had existed for 1,000 years. Norman farmers, clearing stones from their fields generation after generation, had stacked those stones along property lines to mark boundaries and contain livestock. Over centuries, the stones became earthen banks. The earthen banks sprouted brush, brambles, and trees. The trees sent roots deep into the earth, binding everything together into walls more solid than concrete. By 1944, those ancient agricultural boundaries had created a landscape that military planners in London and Washington had somehow, catastrophically, failed to understand. American intelligence officers knew about the bocage. It appeared on maps. Aerial reconnaissance had photographed it. But nobody had grasped what it meant tactically. Nobody understood that Normandy wasn't open country where armor could maneuver and infantry could advance under covering fire. Instead, it was a maze of tiny irregular fields, none bigger than 300 feet across, each one surrounded by walls 12 to 15 feet high. The fields connected through sunken lanes that had been worn into the earth over centuries, narrow passages where German machine gunners could set up interlocking fields of fire. Every hedgerow was a fortress. Every field was a killing ground, and there were thousands of them, stretching inland from the beaches all the way to Saint-Lô and beyond. The Germans had recognized the bocage's military value within hours of the invasion. While American commanders were still celebrating the successful D-Day landings, German officers were pulling their surviving units back from the beaches and organizing them along the hedgerows. They dug foxholes directly into the earthen banks, giving their infantry overhead protection from artillery. They positioned machine guns at the corners of fields, creating crossfire zones. They concealed anti-tank guns behind the vegetation, invisible until they fired, and they waited. American infantry advancing through the bocage faced an enemy they couldn't see. A single German machine gun crew, well positioned in a hedgerow, could pin down an entire company. Mortars fired from behind one hedgerow could drop shells accurately into the next field over. Snipers hidden in the dense foliage picked off American officers and tank commanders. The fighting became a nightmare of close-quarters combat, where traditional advantages, air superiority, artillery, armor, meant almost nothing. An American battalion advancing through the bocage in June 1944 might take an entire day to capture 3 fields, and lose 50 men doing it. The tanks were supposed to help. The M4 Sherman, backbone of American armored forces, mounted a 75mm gun and carried enough armor to shrug off small arms fire. In open country, Sherman tanks could maneuver, flank enemy positions, exploit breakthroughs. But the bocage wasn't open country. Roads between the hedgerow fields were narrow, exposed, and covered by German anti-tank weapons. Any Sherman that tried to use the roads got hit from concealed positions. So tankers tried to go cross-country, through the hedgerows themselves. That's when they discovered how thoroughly the terrain negated their advantages. A Sherman trying to bull through a hedgerow would climb the earthen bank, nose pointed upward, treads churning for purchase. For a few seconds, the tank would be nearly vertical, suspended on the hedge, its entire underside exposed. The underside armor on a Sherman measured barely an inch thick. German troops armed with Panzerfausts, the shoulder-fired anti-tank weapons, would wait for that moment. One rocket into the belly, and the Sherman would erupt in flames, crew screaming as they tried to escape through hatches that opened upward, against gravity, while fire filled the interior. Even if a Sherman made it over a hedgerow without getting hit, the violence of the crossing damaged the tank. The transmission would slam into the ground on the far side. Suspension components would crack. The tank would often stall, immobilized in the middle of an open field, completely vulnerable. Tank crews learned quickly that trying to cross hedgerows was suicide. But if they couldn't cross the hedgerows, they couldn't support the infantry. And if tanks couldn't operate effectively, the entire American offensive ground to a halt. By late June 1944, 6 weeks after D-Day, First Army was stuck. Over 1 million Allied troops had come ashore in France, but they occupied a bridgehead barely 50 miles wide and 20 miles deep. General Omar Bradley's forces were supposed to have reached Saint-Lô within days of the invasion. Instead, they were still fighting for it, one field at a time, taking staggering casualties for gains measured in hundreds of yards. Infantry companies that had landed in Normandy at full strength were down to 30 or 40 men. Rifle companies were losing 60% of their enlisted men and 68% of their officers. The 90th Infantry Division alone suffered 2,400 casualties in June, then another 5,300 in July. The hedgerows were doing exactly what German commanders had hoped. They were bleeding the American army white, buying time for Germany to move reinforcements into position, turning what should have been a breakthrough into a grinding war of attrition. And the Americans, despite their overwhelming advantages in men and material, couldn't find a way through. Combat engineers tried using explosives to blast holes in the hedgerows. The explosions drew immediate German artillery fire and didn't create gaps wide enough for tanks anyway. The army had 4 experimental bulldozer tanks per battalion, Shermans fitted with dozer blades that could theoretically carve through the vegetation. But dozer tanks were slow, conspicuous, and German anti-tank gunners made them priority targets. By early July, after 4 weeks of constant combat, First Army was losing tanks faster than replacements could arrive. Officers and enlisted men both understood they were fighting the wrong kind of battle with the wrong kind of equipment. One infantry lieutenant described the bocage as solving every defensive problem simultaneously. The Germans could see attackers approaching without being seen themselves. They had overhead protection from artillery. They could retreat through covered routes the moment a position became untenable. Meanwhile, American attackers were crossing open ground under observed fire, completely exposed, unable to coordinate artillery support because they couldn't see targets. Tank infantry coordination, the foundation of American combined arms doctrine, was nearly impossible when infantry and tanks couldn't maintain contact through the thick vegetation. General Bradley knew he was running out of time. The Allied invasion plan depended on breaking out of Normandy, not getting stuck there. British and Canadian forces around Caen were fighting German armoured divisions to a standstill, taking horrific casualties themselves. But if the Americans couldn't break through at Saint-Lô, the entire campaign would fail. The longer First Army stayed pinned in the bocage, the more time Germany had to prepare defences deeper in France. Every day of delay gave the Germans another day to move panzers west, to build fortifications, to organise counterattacks. Bradley needed a breakthrough. He needed it before German reserves arrived in strength. and he needed it despite terrain that seemed designed specifically to prevent exactly that kind of mobile warfare. The solution came from the kind of place solutions often come from in war. Not from staff officers or planning committees, but from soldiers close to the problem, improvising with what they had. Multiple units were working on hedgerow-busting devices simultaneously in early July. The 79th Infantry Division had one version, the 19th Corps demonstrated another. But the design that would actually work, the one that would equip hundreds of tanks in time for the breakthrough, came from a sergeant in the 102nd Cavalry Reconnaissance Squadron. Curtis Cullen was 29 years old, from New Jersey, a tank sergeant who'd been in Normandy since the invasion. He'd watched Shermans try to cross hedgerows. He'd seen tanks destroyed, crews burned alive. And he'd listened to a soldier from Tennessee make an offhand suggestion during a bull session about tactics. The Tennessean, whose name was Roberts, said something that sounded ridiculous at first. "Why don't we put saw teeth on the front of the tank and cut through the hedges?" Most of the men laughed. Cullen didn't. He understood what Roberts meant. Not sawing through the vegetation, that wouldn't work. But cutting through the earthen bank itself, using the tank's weight and power to drive steel blades into the base of the hedgerow, pinning the front end down so the tank stayed horizontal instead of climbing. If you could keep the Sherman level as it pushed through, you'd never expose the vulnerable belly armor. The tank would burst through the hedge under a shower of dirt and branches, staying low, staying protected, coming through at speed with the gun able to engage immediately. Cullen started sketching. He needed blades that were angled, sharp at the tips, strong enough to penetrate packed earth and centuries-old root systems. The blades had to be spaced to bite into the hedgerow at multiple points, distributing the force. And they had to be welded onto the Sherman's bow in a way that wouldn't interfere with the tank's other systems. He showed his sketches to his commanding officer, who showed them to higher command. Within a week, Cullen had fabricated a prototype from scrap metal. The steel came from those German beach obstacles, Czech hedgehogs. The very barriers that were supposed to stop the invasion were being repurposed into weapons for breaking through France. There was a brutal poetry to that, turning Hitler's defences into tools for his defeat. The hedgehog beams were high-quality steel, heavy enough to stand up to being rammed into hedgerows, and they were lying everywhere in salvage piles. Cullen and his team cut them into sections, ground the ends to sharp points, and welded them to the front of a Sherman. On July 14th, Lieutenant General Omar Bradley watched the test. The modified Sherman backed up, revved its engine, and charged the hedgerow at 10 miles per hour. The steel tusks bit into the earthen bank, dirt fountained upward, the tank's bow stayed level, and the Sherman exploded through the far side, ready to fight. Bradley watched in awe. Then he gave the order that would change the campaign. "Make as many as possible, fit them to every tank we have. Do it now." That's when Joseph Apple's war became about welding steel under camouflage netting in a forest in France. The order went to Colonel John Murderous, Army Ordnance Department. 3 out of 5 tanks in First Army needed these devices before Operation Cobra, the massive breakout offensive scheduled for late July. That meant fabricating over 500 hedgerow cutters in less than 2 weeks. Murderous didn't have 2 weeks, he had days. The weather was clearing. Cobra was going to launch whether the tanks were ready or not, so Murderous did what desperate officers do. He commandeered every ordnance company in Normandy, flew back to England to strip the depots of welding rod and oxygen acetylene cylinders, had the equipment flown to France before breakfast the next morning, and put every available welder on round-the-clock production. The 111th Ordnance Company, Joseph Apple's unit, got the order on July 15th. They'd been attached to the 29th Infantry Division, then transferred to the 2nd Infantry, running field maintenance out of a forest, near Cerisy-la-Forêt. Their normal job was repairing damaged vehicles, replacing worn parts, keeping the division's trucks and half-tracks running. Now they were manufacturing weapons. Lieutenant Brooks, the company's executive officer, gathered the welders and explained what needed to happen. They were going to work day and night. They were going to weld under camouflage because German artillery could reach their position. and they were going to build as many hedgerow cutters as they physically could before Cobra kicked off. The fabrication process was straightforward but labor-intensive. Each cutter started with German hedgehog beams, already cut to rough length by engineers. The welders had to grind the ends into sharp points using portable grinding wheels. Then they had to cut crossbars from additional steel stock, creating the framework that would mount on the Sherman's bow. The tusks, typically 4 or 5 per device, had to be welded to the crossbar at precise angles, 45 degrees from horizontal, spaced evenly to distribute force. Finally, the entire assembly had to be welded onto mounting brackets that bolted to the tank's transmission housing and front hull armor. Every weld had to be solid. A weak joint would crack when the tank hit the hedgerow at speed, and a cutter coming loose could jam the tracks or damage the suspension. The welders worked with arc welding equipment, heavy cables running from portable generators, welding rod that had been flown in from England because French depots didn't have enough stock. The work was hot, even under the camouflage netting. Sparks scattered across the forest floor. The smell of burning metal and ozone filled the air, and the Germans knew something was happening. Artillery fell intermittently on suspected American positions. The welders learned to work through the distant crump of shells, stopping only when fire got close enough to shake the ground. Joseph Apple was one of the lead welders, 28 years old, steady hands, years of experience working industrial steel before the war. He'd joined the 111th in Texas back in 1940, had gone through training at Camp Bowie, then Louisiana maneuvers, then more training in Wales before shipping to Normandy. He'd been welding all his adult life. He knew how to read steel, how to judge heat by color, how to lay a bead that would hold under stress. Now that skill mattered more than it ever had. The hedgerow cutters he was building were going to take Sherman tanks through walls that had stopped the entire American offensive for 6 weeks. If the welds held, crews lived. If they failed, men died. It was that simple. The quality of each device depended entirely on the welder's skill. There were no standardized jigs, no assembly line precision. Each cutter was hand-fabricated in the field, cut and welded by men working under tactical conditions. Some welders were better than others. Some cutters came out perfect, others needed rework. Brooks walked the line constantly, inspecting welds, sending back pieces that didn't meet standard. They couldn't afford failures once these tanks went into combat. The modifications had to work the first time, under fire, when there wouldn't be second chances. The work ran day and night in shifts. Welders would work 6 hours, sleep 4, then go back to the line. The 111th wasn't the only unit building cutters. Other ordnance companies across the First Army were doing the same thing, using the same salvaged German steel, following the same basic design. But each unit worked independently, adapting the concept to local conditions and available materials. Some devices had 4 prongs, some had 5. Some mounted flush to the bow, others extended further forward. The principle remained constant. Steel teeth, angled blades, weld them solid. Make them strong enough to bite through 1,000 years of Norman agriculture. By July 20th, the 111th had completed 53 cutters. By July 22nd, they'd finished 84. The pace was punishing. Men worked until their arms shook from fatigue, then worked longer. Welding rod ran short, then was resupplied. Generators broke down, got fixed, kept running. The forest clearing became a factory, organized chaos of grinding wheels, welding arcs, finished cutters stacked and ready for installation. Tank crews from the divisions would drive their Shermans into the clearing. Apple and his team would bolt and weld the devices onto the bow, and the tanks would roll out with steel tusks, ready to rip through France. The men doing the work understood what was at stake. They'd seen the casualty reports. They knew how badly the offensive was stalled. They'd talked to infantry replacements coming through from the beaches, heard the stories about hedgerow fighting, about German machine guns and mortar fire, about companies reduced to platoon strength in days of times, combat. The cutters represented hope. Not guaranteed success, but at least a chance, a way to get armor through terrain that had made armor useless. a tool that might tip the tactical balance just enough to break the stalemate. On July 24th, General Bradley postponed Operation Cobra. Weather. Heavy clouds over Normandy meant bomber support couldn't guarantee accuracy. The offensive needed massive air support to crack open the German defences before the armour and infantry went in. Bradley wanted 3,000 aircraft, dropping bombs on a narrow section of front near Saint-Lô, creating a gap that 7th Corps and 8th Corps could exploit. But if the bombers couldn't see their targets through the clouds, they'd drop ordnance on American positions. It had already happened once in a preliminary run, killing over 100 American soldiers. Bradley wasn't going to risk another fratricidal disaster. The attack would wait for clear skies. The delay gave the Welders one more day. By the morning of July 25th, when Cobra finally launched, approximately 600 tanks in First Army were equipped with hedgerow cutters. That represented 60% of the armour that would spearhead the breakthrough. 3 out of 5 Shermans charging south from Saint-Lô had steel teeth welded to their bows by men like Joseph Apple, working under camouflage in forest clearings, turning German beach obstacles into weapons for liberating France. The morning of July 25, 1944, dawned clear over Normandy. After days of rain and heavy clouds, the sky opened blue and empty, perfect weather for what General Bradley was about to unleash. At 9:38 in the morning, 600 Allied fighter bombers screamed in from the English Channel and began hammering German positions along a narrow strip of the Saint-Lô to Perrier Road. For the next hour, 1,800 heavy bombers from the 8th Air Force saturated a rectangular area, roughly 3 miles wide and just over a mile deep, dropping nearly 3,300 tons of high explosive and incendiary bombs. Then came a third wave of medium bombers, finishing what the heavies had started. The bombardment was supposed to approach parallel to the front line, flying east out of the sun along the road to minimize the risk of hitting American positions. Most of the pilots ignored that directive and flew in perpendicular from the north instead, the standard bombing approach they'd been trained on. Bombs fell short. American soldiers in forward positions, men who'd pulled back 1,200 yards from the target zone, watched in horror as ordnance landed on their own lines. The 30th Infantry Division took the worst of it. 111 men killed, nearly 500 wounded, by their own bombers. Among the dead was Lieutenant General Leslie McNair, the highest-ranking American officer killed in Europe, standing in a forward observation post when a bomb struck directly overhead. But the damage to the Germans was catastrophic. The Panzer-Lehr Division, holding the section of front that took the brunt of the assault, effectively ceased to exist as a fighting force. General Fritz Bayerlein, commanding Panzer-Lehr, reported that his division was annihilated. Armour wiped out, personnel casualties or missing, headquarters destroyed, all records lost. Approximately 2,500 German soldiers died in the bombing. Tanks were overturned. Command posts vanished. Communications lines were severed. And the survivors, those who'd somehow lived through 60,000 bombs falling on 12 square kilometres of Norman countryside, were so shell-shocked they couldn't organise coherent resistance. The geography itself was transformed. Where neat hedgerow fields had stood that morning, the landscape now resembled the moon. Craters 30 feet across, overlapping, filled with shattered trees and burning vegetation. Villages were erased. The commune of La Chapelle-en-Jouga simply ceased to exist, wiped from the map by high explosive. Roads disappeared under rubble. And into this devastation, carrying steel teeth welded to their bows, came the Shermans. The initial advance was cautious. 7th Corps, commanded by Major General J. Lawton Collins, sent the 9th Infantry Division and the 4th Infantry Division forward first, feeling for the depth of German resistance. Progress was slow on the morning of the 25th. Bomb craters made the terrain nearly impassable. Rubble blocked roads. German survivors, fewer than expected but still dangerous, fired from positions that had somehow survived the bombardment. By evening, the front line had advanced only about 2 kilometres. Bradley was worried. The breakthrough hadn't broken through yet. But German prisoners told a different story. They were still in shock from the bombing. Their units had disintegrated. Officers were dead or missing. Radio communications were gone. Nobody knew where friendly forces were or what orders to follow. The Germans who'd survived were trying to retreat, not hold ground. American commanders decided to increase pressure. On the morning of July 26th, the 2nd Armored Division and the 1st Infantry Division joined the attack, and that's when the hedgerow cutters proved their value. Lieutenant Colonel James Bates, commanding a battalion in the 67th Armored Regiment, 2nd Armored Division, was leading Shermans equipped with the Cullen devices. His tanks hit the first hedgerow line south of the bombardment zone, moving at 10 miles per hour, the steel tusks angled forward, engines roaring. The cutters bit into the earthen banks exactly as designed. Dirt fountained upward. Branches snapped. Root systems that had anchored the hedgerows for centuries tore apart under the force of 30 tons of armor driving forward behind sharpened steel. The Shermans burst through, staying level, guns traversing immediately to engage any German position on the far side. What had taken hours using explosives or bulldozers now took seconds. A hedgerow that would have stopped an unmodified Sherman completely was just an obstacle to punch through. Tank commanders reported they could cross 4 or 5 hedgerows in the time it used to take to cross one. More importantly, they could do it without exposing their vulnerable belly armor, without stopping to wait for engineers, without becoming stationary targets for German anti-tank guns. The rhinos, as soldiers were calling them, restored mobility to American armor in terrain that had made mobility impossible. The tactical impact was immediate and dramatic. On July 26th, Combat Command A of the 2nd Armored Division reached Cerisy, over 6 kilometers beyond the start line. The 1st Infantry Division pushed through to Marigny, fighting German paratroopers who were fleeing south in disorder. By July 27th, organized German resistance was crumbling. The 30th Infantry Division, despite its casualties from friendly fire, reported that evening that the whole thing had busted wide open. Bradley wrote to Eisenhower the next day saying things on our front really look good. The hedgerow cutters enabled exactly the kind of rapid exploitation that Bradley's plan depended on. Tanks no longer had to use roads or wait for engineers to blast gaps. They could move cross-country at will, while German armor, lacking similar devices, remained road-bound. American Shermans could flank German positions by going through hedgerows the Germans thought were impassable. They could appear from unexpected directions, hit defensive positions from the side or rear, keep moving before German troops could organize counterattacks. Tank-infantry coordination improved dramatically. Infantry could follow directly behind the rhinos, using the tanks as mobile cover, while the tanks used their guns to suppress German firing positions. When a Sherman, equipped with cutters, punched through a hedgerow, infantry would pour through the gap immediately behind, securing the field before German troops could react. Then the tank would hit the next hedgerow, and the process would repeat. Fields that had taken an entire day to capture in June were falling in minutes in late July. The speed of advance caught the German command structure completely off guard. General Paul Hauser, commanding the German 7th Army, had been expecting a slow, grinding offensive like the previous 6 weeks of fighting. Instead, American armor was advancing several kilometers per day, bypassing German strongpoints, cutting off retreat routes, creating chaos in the German rear areas. On July 28th, German units tried to establish a new defensive line east of Coutances. American tanks equipped with hedgerow cutters simply went around them through country the Germans thought was impassable, forcing another retreat. By July 30th, 4th Armored Division was approaching Avranches, the gateway from Normandy into central France. Combat engineers bridged the River Seine, and armored columns crossed in 2 directions. One column hit stiff resistance and lost 8 half-tracks before halting. The other column pressed toward Avranches, passed within a few hundred yards of Hauser's headquarters without knowing it, found intact bridges over the River Sea, and entered the town, which was undefended. When that news reached General Troy Middleton commanding 8th Corps, he immediately ordered reinforcements forward to seize bridges at Pontaubon, 4 miles south. Those bridges controlled access to Brittany. If American armor could secure them, the entire German position in Normandy would collapse. The breakthrough that had seemed impossible in June was happening in days in late July. The difference wasn't just the aerial bombardment, though that helped. It wasn't just superior numbers, though the Americans had that. The critical factor was mobility. American armor could move through terrain that German commanders thought would channel any attack onto predictable routes. The hedgerow cutters, those improvised devices welded together from German beach obstacles in forest clearings by men like Joseph Appel, had restored the fundamental advantage that armor was supposed to provide. Speed. Maneuver. The ability to exploit success before the enemy could react. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. German casualties in Operation Cobra were staggering. By July 31st, 7th Army had lost approximately 10,000 men killed, wounded, or captured. 100 tanks destroyed, 250 other vehicles lost. Entire divisions reduced to regimental strength. The Panzer Lehr Division, once an elite armoured formation, was functionally destroyed. The 352nd Infantry Division, which had fought since D-Day, was in ruins. German units were retreating in disorder, abandoning equipment, losing cohesion. American losses were significant, but dramatically lower than the June fighting. First Army suffered approximately 1,800 casualties during the initial bombardment and breakthrough attempts. That included the friendly fire deaths, which accounted for about 10% of the total. But compared to the 40,000 casualties taken in June and early July fighting through the same hedgerow country, Operation Cobra was almost a bargain. The breakthrough cost lives, but far fewer than the grinding attrition warfare that had preceded it. Tank crews equipped with the Kulin devices reported that the modifications worked exactly as advertised. The cutters could punch through any hedgerow they encountered. The welding held up under repeated impacts. Maintenance was minimal, usually just clearing dirt and vegetation from between the prongs. Some crews reported the devices actually improved their tank's frontal protection, since the steel prongs created a kind of improvised spaced armor that could deflect or detonate Panzerfaust rounds before they hit the hull. There were variations in effectiveness depending on the specific design. The 3rd Armoured Division had developed its own version, called the Douglas device, distinguished by triangular plates on both sides of the prongs. Some crews preferred 4-prong designs, others liked 5 prongs better. The quality varied based on which ordnance company had fabricated the device and which welder had done the work. But even the worst hedgerow cutter was vastly better than no cutter at all. Tanks without the modification were essentially useless in the bocage. Tanks with cutters could fight. By August 1st, when 3rd Army officially activated under General George Patton, the strategic situation had transformed completely. 1st Army under General Courtney Hodges continued pushing south and east. 3rd Army, fresh and aggressive, poured through the Avranches Gap and fanned out into Brittany. German forces in Normandy, which had successfully contained the Allies for nearly 8 weeks, suddenly found themselves outflanked, encircled, and fighting for survival rather than defending prepared positions. The bocage, which had seemed like an impenetrable defensive barrier in June, was now behind American lines. The hedgerows that cost 40,000 casualties to penetrate had been breached. Not by changing the terrain, but by adapting the equipment to match it. Steel teeth. Welded steel. The kind of field modification that staff officers in Washington would never have approved, fabricated by ordnance companies working under fire, using enemy steel salvaged from invasion beaches. It was improvisation at its finest, soldiers close to the problem solving it with the tools they had. Joseph Appel and the other welders of the 111th Ordnance Company didn't witness this breakthrough firsthand. They were still in the forest near Cerisy-la-Forêt, maintaining vehicles and building more hedgerow cutters for replacement tanks arriving from England. But they heard the reports. They saw the maps showing American advances measured in kilometers rather than meters. They talked to tank crews rotating back for maintenance, men who'd been through the hedgerows with the cutters, who described bursting through vegetation that would have killed them weeks earlier. The psychological impact on American troops was profound. For 6 weeks, soldiers had watched the bocage swallow entire divisions. They'd seen companies reduced to platoons, battalions rendered combat ineffective, the whole offensive grinding to a bloody stalemate. The hedgerows had seemed invincible, a problem without a solution. Then the cutters appeared, and suddenly the terrain that had stopped everything became just terrain, crossable, defeatable. The enemy still fought hard, but now Americans could get at them, could maneuver, could use their advantages in armor and mobility instead of being neutralized by geography. German morale, conversely, collapsed. Soldiers who'd watched the bocage stop American attacks for weeks suddenly found Shermans coming through hedgerows at speed, appearing from directions that should have been impossible. The psychological advantage shifted. Germans had relied on terrain to equalize the material imbalance. When that terrain stopped working, when American tanks could go anywhere, German infantry lost confidence in their defensive positions. Retreats became routes. Units disintegrated. Officers lost control of their men. Field Marshal Gunther von Kluge, commanding German forces in the west, tried to organize counterattacks. He moved the 2nd SS Panzer Division west. He pulled elements of the 116th Panzer Division from the British sector. He scraped together whatever armor he could find and launched Operation Lüttich on August 7th, a desperate attempt to cut the American corridor at Mortain and restore the front. The attack failed catastrophically. American forces, now fully out of the bocage and operating in more open country, destroyed the counter-attacking panzers with a combination of air power, artillery, and tanks that could maneuver freely. The Falaise Pocket, the great encirclement that destroyed the German 7th Army, became possible only because Cobra had worked, only because American armor had broken out of Normandy, only because the hedgerows hadn't stopped them. By August 21st, when the Falaise Pocket closed, approximately 50,000 German troops were dead and 200,000 captured. The German position in northwestern France had ceased to exist. The road to Paris was open. The race across France had begun. None of that would have happened on the timeline it did without the hedgerow cutters. The steel teeth that Joseph Appel and hundreds of other welders fabricated in July 1944 enabled Operation Cobra. They didn't make victory inevitable. Soldiers did that with their blood. But the cutters made victory possible. They solved a tactical problem that had stopped the entire Allied offensive. They turned American armor from liability into asset in terrain where armor shouldn't have worked. And they did it just in time. The official after-action reports from First Army acknowledged the role of the modifications. Tank commanders submitted detailed assessments praising the devices. Infantry officers noted that armoured support became effective again once tanks could cross hedgerows under their own power. Artillery observers reported that advancing through the bocage became feasible when tanks could move continuously rather than stopping at every hedge. The consensus was clear. The rhinos worked. They worked better than anyone had expected, and they worked when it mattered most. General Bradley later wrote that the hedgerow cutters were critical to the success of Cobra. General Eisenhower, in a 1961 speech, specifically mentioned Sergeant Kulin's innovation as an example of American ingenuity in combat. Both generals understood that battles aren't won just by strategy and firepower. They're won by solving practical problems. And in Normandy, the practical problem was hedgerows. The solution was steel teeth. The implementation was welders working under camouflage, day and night, turning scrap metal into weapons. By late August, as American armies swept across France, the hedgerow cutters became less necessary. The terrain changed. Open country replaced bocage. Tank warfare returned to maneuver and exploitation, the kind of fighting American doctrine was designed for. Many crews removed the cutters to reduce weight and improve speed. Some kept them as improvised armor. Others left them welded on as good luck charms. But the critical period, the 2 weeks when Cobra broke the deadlock, those cutters were, on nearly every Sherman spearheading the advance. Production of the devices continued through August and September as replacement tanks arrived in theatre. Ordnance companies across France fabricated cutters using the same basic design, still using salvaged German steel when available, switching to regular steel stock when the hedgehog piles ran out. The process became standardized. Diagrams circulated showing optimal prong angles and spacing. Welding specifications were written down. What started as field improvisation became official modification. The British developed their own versions. Churchill tanks equipped with prong devices operated during Operation Bluecoat, the British offensive supporting Cobra. Canadian forces used similar modifications. Even some tank destroyer units fitted cutters to M10S and M18S. The concept spread wherever armies faced hedgerow terrain. But the American versions, fabricated in Normandy in July 44, were the first and most numerous. They equipped the tanks that broke the stalemate. Joseph Apple continued his work through the fall of 1944. The 111th Ordnance Company followed 1st Army through France, Belgium, and into Germany. They maintained vehicles, repaired battle damage, built whatever modifications field commanders requested. Apple welded all the way to the German border, through the winter of 44-45, through the Battle of the Bulge, right up to VE Day in May 1945. After the war, he went home to civilian life and kept welding. He worked at it for another 25 years, retired, and died in the early 1970s. His obituary mentioned he'd served in the war. It didn't mention the hedgerow cutters. Lieutenant Arthur Brooks, who'd supervised the fabrication work and kept the 111th running through Normandy, took command of the company in January 1945 and led it until the unit deactivated in October. He lived to be 96 years old and spent his final decades telling anyone who'd listen about the men he'd commanded. When historians interviewed him about the hedgerow cutters, he emphasized that it wasn't one person's achievement. It was welders working round the clock. It was engineers cutting steel. It was tank crews testing the devices under fire. It was the whole system adapting, learning, solving problems. Curtis Coolin, whose name became synonymous with the invention, was awarded the Legion of Merit for his innovation. He tried repeatedly to give credit to Roberts, the Tennessee soldier who'd made the original suggestion. But in the publicity surrounding the breakthrough, Roberts' name was forgotten, and Coolin became the face of American ingenuity. He accepted the recognition with humility, always emphasizing that many units were working on similar ideas simultaneously. Later that year, Coolin lost a leg to a landmine in the Hurtgen forest. He returned to the States, married, worked as a liquor salesman in New York, and died in 1963. His contribution to the war was commemorated with a plaque in his hometown of Cranford, New Jersey. The hedgerow cutters saved lives. That's difficult to quantify precisely, but the numbers tell a story. In June and early July, 1st Army took 40,000 casualties, capturing 20 miles of hedgerow country. In late July and August, using tanks equipped with cutters, American forces advanced over 100 miles in weeks, suffering dramatically lower casualties relative to ground gained. The difference wasn't just tactics or firepower, it was mobility, the ability to move through terrain that had been impassable. That ability came from steel teeth welded onto tank bows by ordnance companies working in forests under fire. Tank crew survival rates improved markedly once cutters became standard. Tanks could cross hedgerows without exposing vulnerable undersides to panzerfausts. They could advance continuously, rather than stopping to wait for engineers. They could maneuver to avoid German anti-tank guns, rather than being channeled onto predictable routes. Combat reports from August show significantly fewer Sherman losses to anti-tank fire compared to June, despite facing the same German weapons. The cutters didn't make Shermans invulnerable, but they made them survivable in terrain where they'd been death traps. The hedgerow cutters disappeared from American tanks by autumn 1944, removed as armies raced across France into terrain where they were no longer needed. But what they represented, field modification solving tactical problems faster than official channels ever could, that legacy became permanent. The United States Army doesn't traditionally embrace unauthorized innovation. Military organizations run on standardization, on approved procedures, on equipment that's been tested and certified. Soldiers aren't supposed to modify their weapons in combat zones. Welders aren't supposed to redesign tanks. Sergeants aren't supposed to solve problems that entire engineering departments failed to anticipate. But Normandy proved that sometimes the men closest to the problem see solutions that staff officers in distant headquarters miss entirely. After the war, the army studied what happened in the bocage. They examined why pre-invasion planning had failed to recognize the hedgerows as serious obstacles. They analyzed how field units had adapted faster than the official supply system could respond. And they documented the entire hedgerow cutter story, from Robert's suggestion to Culin's prototype to the mass production by ordnance companies, as a case study in battlefield innovation. The lesson wasn't that armies should abandon planning and let soldiers improvise everything. It was that successful organizations need mechanisms for rapid adaptation when plans meet reality. The German beach obstacles sitting in salvage yards weren't supposed to become tank modifications, but someone recognized the potential. Someone else built a prototype, and commanders with authority made the decision to implement immediately rather than waiting for approval from higher headquarters. That speed of decision-making, from concept to mass production in 2 weeks, saved the Normandy campaign. Modern military doctrine about rapid fielding and urgent operational needs traces directly back to Normandy. The idea that battlefield commanders can request immediate modifications, that field units can fabricate solutions using available materials, that innovation doesn't always flow top-down from research laboratories. All of that became formalized because of experiences like the hedgerow cutters. The United States Army established formal programs for harvesting soldier ideas, for testing field modifications quickly, for pushing successful adaptations across the force before the tactical situation changes. Tank design philosophy changed too. Post-war armor development emphasized adaptability. Tanks needed to perform in multiple terrain types, not just open country. Designers started thinking about obstacles differently, not as problems to avoid, but as challenges to overcome through engineering. The M26 Pershing, the M46 Patton. Every American tank design from 1945 onward incorporated lessons from the bocage, not necessarily by including permanent hedge-cutting equipment, but by designing hulls that could accept field modifications, by building in mounting points for additional equipment, by assuming that combat would reveal requirements nobody predicted. Other armies learned similar lessons. Soviet tank designers studying American combat reports noted the effectiveness of improvised modifications. British armor doctrine emphasized combined arms problem-solving, recognizing that infantry, engineers, and tankers working together could overcome obstacles that any single arm couldn't handle alone. The principle became universal. Terrain is never neutral. Equipment must adapt to terrain, not the other way around. The welders who built the hedgerow cutters were never celebrated the way Culin was. Joseph Apple didn't receive a Legion of Merit. The hundreds of men in ordnance companies across Normandy who worked day and night fabricating cutters, who welded under camouflage while German artillery fell nearby, who turned piles of scrap steel into weapons that broke the deadlock. They went home after the war to regular jobs and regular lives. Some kept welding. Some never touched a torch again. Most never talked much about what they'd done. But their work changed history in measurable ways. Operation Cobra succeeded because American armor could move through hedgerows. The Falaise pocket closed because 7th Army couldn't retreat faster than 3rd Army could advance. Paris was liberated in August instead of October because the Normandy stalemate broke in July. The war in Europe ended in May 1945 instead of dragging into 1946 because Allied forces maintained momentum after the breakout. You can draw a direct line from steel teeth welded in French forests to German surrender 9 months later. The broader lesson transcends World War II. In any complex undertaking, whether war or industry or exploration, success depends on solving problems that weren't anticipated during planning. The organizations that succeed are the ones that empower people close to problems to develop solutions, that move fast from concept to implementation, that value results over process. The United States Army in Normandy didn't solve the hedgerow problem through superior planning. They solved it through adaptation, through recognizing good ideas regardless of who suggested them, through commanders willing to bet on field modifications rather than waiting for perfect solutions from headquarters. Joseph Apple died decades ago. The 111th Ordnance Company was deactivated in October 1945. The Shermans that fought in Normandy were scrapped or sent to allies or put in museums. But the principle that a welder with a torch and some scrap steel can change the course of battles, that principle endures. Innovation happens at the edge, where doctrine meets reality. And sometimes, when armies are stuck and conventional solutions have failed, the answer comes from unexpected places, from a Tennessee soldier making an offhand suggestion, from a sergeant willing to try something new, from welders working through the night under camouflage, turning the enemy's defenses into tools for his defeat. The hedgerow cutters weren't perfect. They weren't elegant. They were crude steel prongs welded to tank bows using salvaged German obstacles and whatever welding rod could be scrounged from depots in England. But they worked. They worked when it mattered, and that's the only standard that matters in war. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.